lectures longer than Khan has been recording stuff for his niece that was seen by Bill Gates. Bill Gates didn't see my stuff, so I didn't get the millions and millions of
He's got a good voice. Like, he has a good voice.
True, but okay.
That's what makes him nice.
All right, so coming back out to you is old homework, and then I'll come by and give you a quick mark on your N.
Oh my god, I'm so pissed I didn't freaking get it.
Yeah.
That's b squared minus 4ac. It's whatever was underneath.
I'm just never here. Oh, right.
You have
Okay.
I don't know why, but I accidentally did K.
You have it on there. I know this stuff. I have it.
But that's what my parents was.
Man on campus.
Yeah.
But it actually works.
I can do whatever I want. Thanks. Alright.
No.
You should almost keep it on. We almost got confidence and shot it on.
Nice. Does anyone paint?
Leak through all the padding onto my sock. Now I have 2 bloody socks.
I really? Yeah, I really.
All right. Lights, please.
No. We don't run, we walk and jog.
All right. So, ladies and gentlemen, it's nice to see you. So, tomorrow we will have a quiz. Portion of the quiz will be on Schoology, which is nice.
Yeah, you should move it back.
Wait, what's today? Today's Wednesday.
Oh, yeah, no.
Algebra 2 quiz.
Let's have another.
And then you have a front and back as the other part. It's tomorrow. So we are having today as quite a bit of review. So let's go. You'll do fine. My goodness, you quit belly aching. You guys all belly aching, you get like an 86% average. And that's because you had one kid who left it blank. All right. Letter N. Questions where we should go from, and don't say all of it. Go ahead.
Can you do some from the graphing?
Okay, so like 4, 5, 6, or
Yeah. 7, 8, 9.
Yeah.
Just that section.
okay.
Main does section.
So let's take a look at. Let's just start out with number 4. They give us a picture that looks like this, right?
Yeah.
And it says this: identify whether the value of the discriminant is equal to 0, positive, or negative. Okay, so the discriminant is b squared minus 4ac. It's the portion that is underneath the quadratic formula. So does that cross the x-axis twice?
Yes.
That means the discriminant, that means this value has to be positive. That's all it means. So if the discriminant is a positive number, it will cross the x-axis twice. Okay? But let's take a look at, like, say, number 5. We'll do this one. Will you give us this? So that touches once, right? So that means the discriminant is 0 there. And then if you go to, say, number 8, that they gave us this, that does not cross the x-axis, so the discriminant would be 0, or negative. So negative here. That's that answer there. That's that answer there. And then it says B, state how many and what type of roots you would have. Does this cross the x-axis?
Yes.
Can you tell exactly where it crosses because your graph is really well labeled?
Yes.
No.
No, but it does cross the x-axis, right?
Yes.
So these are 2 real solutions. Okay? Now, if you could see exactly where it crossed, you would say they'd be 2 real, and they would fall under the rational type of real numbers. But being you can't tell, you do that. This one touches at one time, so this has 1 real. Okay, that's a bounce. And then this one doesn't cross the x-axis, so we have 2 complex, meaning if I solved my equation, I would have I as part of it. Okay?
Wait, what does 2C mean?
Too complex. So these are the imaginary. So this would have meant you had a negative under your square root, which would have meant you have I as part of your answer. 2 real, 1 real, or 2 complex.
So it doesn't matter which way the parabola is?
Doesn't matter if it opens up or down. If it crosses the x-axis twice, you have 2 real. If it bounces off of it, whether it bounces off of it coming down to it or bounces because it's the ceiling and coming down, that means you have 1 real. And then if it does not cross the x-axis, whether it opens up or down, that means you have 2 complex, means you'd have an I as part of your answer. Okay, what else did we come across on? Did that answer those questions?
Yeah.
Cool.
Find the discriminant. You have to go. It's the one under the.
Yeah. So all the discriminant is b squared minus 4ac. Okay. So you'd plug in. You'd have to have it as ax squared plus bx plus c equals 0 or equals y, and then you go b squared minus 4ac. If it's a positive number, that means you have 2 real roots. If it's a negative number, you have 2 complex roots. If it's 0, it would be one of the ones that bounces off of that. Yeah.
I just have like a general question.
Okay.
So when it says like solve the quadratic equation, like find the quadratic formula.
Which one are you on?
What is like for example like 12 when you're
12.
doing it?
Okay.
And you have to times 4 by them. You still have to times 4 by like -3.
Yeah.
Yep.
Yeah, definitely. Here, let me walk through that one. So number 12. So I got 2x squared plus, excuse me, that's minus 5x, right? The first thing is, if you're going to use the quadratic formula, you have to make sure that it's equal to 0. If it's not equal to 0, move things over. Or it can be equal to y as well. So my a value is 2, my b value is -5, my c value is -3. We know that x is equal to -b plus or minus squared b squared minus 4ac all over 2a. Okay? So all of the negatives and signs and numbers that are in there come all the way through the problem. So the 4 and the 2 that happen to be the 4 under the square root sign and the 2 that's in the denominator, they come along with it. The plus minus comes along with it. The negative b comes along with it. So we're going to plug in x is equal to negative plus or minus the square root So where those boxes are the A, B's, and C's. Does that make sense?
Yeah.
So what I'm going to do is now I'm just going to go ahead and plug my A's, B's, and C's in. So I get x equals -b. Well, that's -5. Well, that'll become a +5 later. And then I get -5 quantity squared minus 4 times 2 times -3 all over 2a. Is that okay how I plugged it all in? I have to make sure I realize that I have negative signs that do exist. And there are negatives that when I multiply that change to my sign. So I get -5 plus or minus the square root of 25.
49.
-4 times.
Positive 49.
Oh, it comes out to positive 49, thanks. So that's what? That's -8. -8 positive 24 over 4. Is that okay with the math?
Yep.
Then I get 5 plus or minus the square root of 49. The nice thing is that's a perfect square, agree?
Yeah.
So that's going to give me 5 plus or minus 7 over 4. Do this arithmetic now. So 5 added to 7 is 12. 12 over 4 is 3. 5 minus 7 is -2. -2 over 4 is -0.5. And those are my 2 answers.
So like on the quiz, if we just left it as 5 plus or minus 7 over 4, did you get it wrong? Or like...
Yeah, so that would probably be like a 3-point problem. If you got to here and didn't get to do those, you'd miss one of the points.
Okay.
Okay? So this problem here, can you definitely see what the solutions are equal to?
Yeah.
So these are real solutions, and they are, I just lost my word, I'm sorry. Rational. They are 2 real rational roots because you can see exactly what they are. if your answer came out to this, let's just pretend our answer was this. Those are two irrational roots. Two real irrational roots. Why is that? Well, square root of 7 is a decimal that goes on forever. It doesn't repeat, doesn't have a pattern. Okay, so 3 and negative half are two real rational. 5 plus or minus root 7 over 4, if your answer came into that, would be two real, so it's crossing the x-axis. But that answer right there, 5 plus or minus root 7 over 4, is totally done. You don't have to go any further on it. Okay? Those are two irrational answers. Yeah. Yeah, buddy. 15. Okay. So solve using the quadratic formula. I have negative x squared plus 2x minus 9 is equal to 0. It's equal to 0, so that's good. So my a value is negative 1, my b value is 2, my c value is negative 9. So x is equal to negative b plus or minus the square root b squared minus b squared ac. Alright. It's always the same song.
If we switch the negative sign so the negative x squared is positive, like we multiply the whole thing by negative 1.
Oh, you will get the exact same answer. So what the question was, can I multiply everything by negative? So that'd be positive 1, negative 2, positive 9. The answer is going to be the exact same, which is a nice thing to do. That happens. All right, so negative 2 plus or minus 4 minus 36 over negative 2. Agree? So 4 minus 36 is negative 32. All right, so let's break down negative root 32. It's going to be, you're going to have an I and then 16 times 2. So it's going to be 4I root 2. So I'm going to replace that here. And then what you can do is you have a negative 2 on bottom, so you can divide negative 2. If you divide negative 2 with the plus minus, it still stays plus minus. I guess you could technically say it becomes minus plus, but I'm not looking for that. So this reduces into here, into there. So I get 1 plus or minus 2I root 2 for an answer.
But the negative 2 cancels out at the start.
It would cancel out here, yeah, because negative 2 goes into all of these outside. And I guess technically you could say it's minus plus versus plus minus.
Okay. But
And
you need a 1 at the start.
Yeah, because negative 2 over negative 2 is positive 1. So it reduces. It's just you're reducing fractions. You're taking 6 over 8 and making it 3 over 4. Yeah.
Can you do 29?
Yep. 29. Write a quadratic. Ooh, okay. So I get x is equal to negative 5 plus I root 15 over 4. And you also get x equals negative 5 minus I root 15 over 4. So you only have to pick one of the sides to solve. Okay, so we'll go ahead and solve this one, okay? So first step, I'm going to multiply the 4, bring it over. Is that okay? Bring the 5 over. Okay, and then now you're going to take a look at it and you're just like, you know what? I'm going to square this and I'm going to square this. So if I FOIL that out, that's going to give me 16x squared plus 40x plus 25 equals I squared times 15. What's I squared equal to? Negative 1. So if that's negative 1, that gives me negative 15. Add 15, bring it over. that right there would give you either of your answers. Yeah.
So is it the same type of thing for 28 then?
28. It's the exact same thing. The only difference is you don't have an I in there, but you're going to go the exact same process.
Okay, are we gonna have some of these on the test tomorrow?
That's what the whole, yours will. Everyone else's is, you know, butterflies and pancakes. Yeah. 20. Yeah, you might. I bet you'll see one like this and one with the I in it. 20. 4x squared equals negative 4x minus 1. So we can either move the 4x squared over by subtracting it, or I could bring the 4x and the 1 over by adding them. So if I bring those over, everything's positive. And so you could go ahead and use the quadratic formula on this. I think you're going to be able to say this is the same thing as 2x plus 1, 2x plus 1. So that's the same thing as 2x plus 1 raised to the second equals 0. So if you go and solve this one, root, and then 2x equals negative 1. So you're going to get x is equal to negative half. This would be one that if you plug in the quadratic formula, your discriminant is 0. So it means it bounces off the x-axis, means you have one real solution, which is negative half.
You did 24.
Yeah. That one? All right, I would move the 4x and the 4 over. Just by looking at it, it appears that my front and my back are both perfect squares. So I think this is going to be the same thing as x minus 2, x minus 2, which is x minus 2 quantity squared is equal to 0, root, x minus 2 is equal to 0, so x is equal to 2. And again, that one, if you plugged in the quadratic formula, your discriminant under the square root sign is going to be 0, so this is a bounce. Okay, why did I choose to factor it, not use the quadratic formula?
It's easier.
Well, some people might think that, but it's faster if you can start recognizing the perfect squares. Your answer isn't wrong, it's just you might start running out of time. And if you had taken the ACT or SAT, you would like to save time. If you can knock those out without saving time, am I going to dock you on it if you don't have it? Any others that you want to take a look at? Yeah.
Can you do 22?
Do. All right, 6x squared minus 24x. So I don't have a C value, correct? And I probably wouldn't approach this problem by trying to work it out with a quadratic formula. I'd recognize I could factor 6x out of both of those, which is going to give me this, which then that says 6x is equal to 0, so x equals 0. There's one root. X minus 4 equals 0, so x equals 4. So if I use the quadratic formula, I'd have a perfect square under the radical, and then I do get two real solutions for it. But that one would have factored that nicely. And again, why would I have not used the quadratic formula? Because it would have taken more time. Because b squared is 24 squared, so you have 676 that you're dealing with. It's 576.
I just divide by 6.
Perfect. Then, yeah, see, that'd make it easier too. There's all kinds of ways to run through them. Is my way always the right way? No. Don't take it from me. As some of my friends in Arizona would say, man, you're just a teacher. You're right.
You're not just a teacher.
Thanks, Dan. I came from my friend Daryl, who's Border Patrol agent. You're just a teacher, yeah? Let's talk about the border. It's fun. We always jab at each other. Anything else? Good? All right, let's go ahead and pass that forward. So pass N on forward. Make sure your name's on it, please.
What? Hope for what? Hope for loser.
I think I can get
How are you today?
Now I know how to do that.
Give me a piece of that, please.
Hello, promise.
Thank you.
We all know this comes with probably 20 grams. I don't eat this. I'll put you like 18.
Oh man, that's not good.
Eat your food.
All right, Lane?
What, yeah.
Yeah. Do a dollar.
Weekend already.
Oh, yeah. Nothing wrong with that.
Is that icing? This is syrup.
Yeah, buddy.
Somebody's ordered that.
Come in my office anytime you want. I'll tell you a story.
What about the knockouts?
Nah, you got maps.
We don't have enough.
Why?
I didn't give enough?
No.
Let's just leave.
Just leave.
Okay.
Sorry about that. These days I will learn to count, my friend. Everyone have a note sheet now. They're coming back. All right, so my goal for today is hopefully review as much as possible. This packet is not, I didn't give you one either. This is not that thick of a packet, so more of the review will be based on what you all might ask. All right, so review of solving by using square roots, quadratic formula, and completing the square. Synthesize, wow, cool. Big words, unless I use it. So you will definitely see a problem like number 200, or root 200 on tomorrow's quiz. So does everyone feel comfortable that that is this?
Heck yes.
Yes.
Okay. You will definitely see a problem like this one on it tomorrow, so you can take it to that. But what should I do next?
Multiply.
By?
Bottom quadratical 5.
So both top and bottom, right? So I get 2 root 5 on top. Root 5 times root 5 is root 25. Root 25 is 5.
Cool.
So you'll definitely see that. Yep.
No.
Nope.
Stop. Yes.
All right, you will definitely see a problem like this where you have to realize I have to multiply both top and bottom by the exact same thing. But what's the special thing about this?
Minus.
Yeah, they're called conjugates. So the minus, that drops out the middle terms when multiplying the bottom. So 3 times 2 is 6, minus 3 times root 3, which is 3 root 3. On bottom, 2 times 2 is 4, minus 2 root 3, plus 2 root 3, minus 3, because root 3 times root 3 is root 9. Root 9 is 3. So those cancel, so you get 4 minus 3, which is 1. So you can leave your answer like that. I wouldn't mark it wrong if you left it like that, or you can make it like this. It's your choice. Any problems with any of those? Was there definite fair game? Definite fair game for it. All right, and then we multiply. So when we multiply these, go ahead and multiply the outside. But understand inside, I'm trying to pull perfect squares out. So I might look at that and say, well, I know 15 is 3 times 5. I know 10 is 2 times 5. And being that there's a pair of these, that means that would make a perfect square. Do you agree? So what comes out? 5. So you wind up with 6 times 5, root 6. And you can multiply that, giving you 30 root 6. And that's as far as you go. Is that all right?
Yep.
May I move on? We're good to go? All right. So solve the quadratic by finding the square root of each side. Your answers may be integers, simplified radicals, or complex numbers. So the first one, I'm going to add 10 to both sides. Do you agree? I take the square root of both sides. Root, plus minus. So I get x minus 5 equals 5, plus or minus 5. Agree? Which is going to give me x equals 5 plus or minus 5. Don't leave it like that. 5 plus 5 is 10. 5 minus 5 is 0. So there's your two solutions there. Second problem, I'm going to add 10, bring it over. So same exact problem, it's just I wind up with this now. Root. Don't forget the plus minus. So I get x minus 5 on this side. Put that in parentheses. Equals plus or minus the square root of 20. Root 20 is going to break down to root 4 times root 5, which that's going to give me 2 root 5. Agree? Mm-hmm. Add 5 to both sides, and your final answer looks like this. 5 plus or minus 2 root 5. Notice I did not convert it to a decimal approximate. So the first one would be 2 real rational roots. The second one would be 2 real irrational roots, because square root of 5 is an irrational number. Okay? And I imagine this last one is going to give us 2 imaginary roots. So add 10 to both sides. Root. Don't forget the plus minus. X minus 5 equals plus or minus 5i. Is everyone comfortable where that came from? Mm-hmm. Add 5 to both sides. So that would be 2 complex solutions. So the first one and the second one both cross the x-axis twice. The third one, if you graphed it, it would not cross the x-axis. And I'm just trying to fill any information that might come with those. How far am I? I'm almost done. Three total. Cool. Can I move on? All right. Simplify complex number expressions. Add, subtract, multiply, divide. Yeah, buddy. So the first one, we're just adding. So we're going to add like terms. 3 and 2 add together give me 5. 5 minus 7i is negative 2i. Done. Mainly on these, the one that you're looking for is when you get I squared, because I squared is equal to?
Negative 1.
Negative 1. Okay, the second problem, we're subtracting. 3 minus 2 is 1. 5 minus 7 is plus 12i. Done. And then when we start multiplying them together, that's going to give me 6 minus 21i plus 10i minus 35i squared. Negative 35i squared is turning into what?
Positive 35.
Positive 35. Positive 35 added to 6 is what?
41.
41 minus 11i. Does everyone feel comfortable how I found that? The things I noted was this right here becomes plus 35 because I squared is negative 1. Negative 1 times negative 35 is positive 35. Yay?
Nay.
Nay?
Hey.
All right.
What's the answer to that?
41 minus 11i. And this one is 10i plus 15i squared. 15i squared is going to convert into what? Negative 15 plus 10i. Watch your order. You want the real then the imaginary portion. So that's why I flip-flopped it a little bit. Ooh, I to the 7th is what? I don't know. Well, I to the 4 goes into 7 how many times?
Once.
Once. How many do you have left over?
3. So it's
So I to the 7th is the same thing as I to the 3rd. I to the 3rd is equal to I squared times I. What's I squared? So what's my answer? Negative I. Careful. Because if that's -1 times I is negative I. So you will always on those divide by 4. Whatever your remainder is, doesn't matter if it goes into a 200 times. Whatever your remainder comes out to, it's either I, which is I to the 1st, I to the 2nd, which is -1, I to the 3rd, which is negative I, and I to the 4th, which is +1. Yeah.
Isn't negative I just +1?
No. Because I is equal to the square root of -1. So they repeat. This is all they do. I equals square root -1. I squared equals -1 because if you square both. I to the 3rd is the same thing as I to the 2nd times I, which is negative I. And then I to the 4th is the same thing as I squared times I squared. -1 times -1 is +1.
Okay.
And then it repeats. That's why you divide by 4. So I to the 5th is the same thing as I to the 6th, same thing as I squared, I to the 7th, I to the 3rd, so on and so forth. Is that okay?
Is I to the 4th the only one that equals 1?
Yes. Yes.
Sweet.
Meanwhile, you're good? All right. Let's see. I'm going to put that in parentheses, put that in parentheses. I'm going to multiply by the conjugate of the denominator. So 2 minus 3i, 2 minus 3i. And I'm going to make myself a little bit more space. All right. Multiply out the top. So I'm going to get 8 minus 12i plus 10i minus 15i squared. And then on bottom, I'm going to get 4 minus 9i squared. Where did the middle stuff go? It drops out, right? So this and this are going to be changing. Okay. Negative 15i squared is positive 15, correct?
Mm-hmm.
Positive 15 added to 8 is 23. Minus 2i. On bottom, negative 9i squared is? Positive 9. So positive 9 added to 4 is 13. There's my answer. Okay, last one. I have 5i to the 27th. Well, the 5 will be multiplied by whatever we get at the very end. How many times does 4 go into 27? Doesn't really matter, but how many? What's left over?
5.
So 3. I to the 3rd, right? Does that make sense how we just did that?
No.
So 4 goes into 27 6 times. How much is left over? 3. Because, 4 goes into 27 6 times. So that's 24, 25, 26, 27. So this is the same thing as 5i to the 3rd. 5i to the 3rd is equal to negative I. So what's my answer? Negative 5i. Perfect. Life okay? Can I move on? Do what I do?
This isn't going to be on our quiz tomorrow, is it?
That's why I said review at the very beginning. I'm giving you a hard time. Are you not wearing your batting helmet any longer?
5-0, are we?
5-0 review.
We go to 5-0.
All right. Complete the square to solve the quadratic formula. I'm going to divide everything by 3 first. So x squared minus 6x plus 2. I'll make my space. Is that okay?
Yeah.
Half of 6 is? 3. 3 squared? 3 squared? 9. If I add 9, I can add 9 onto that side of the equal sign. Or I could subtract 9 from the 2. It's your choice. This is my perfect square trinomial. Agreed? So what does that factor down to?
X minus 3 squared.
Yeah, x minus 3 and x minus 3, which is, bless you, x minus 3 quantity squared, bless you, plus 2 equals 9. x minus 3 squared equals 7. Root, don't forget the plus minus. X equals 3 plus or minus root 7. So that is a 2 real,
Complicated.
not complicated, irrational.
-2 on the other side.
What?
I did. I said subtract 2.
Can you do the beginning also?
Where did the plus 9 come from? I like the beginning.
Oh, right here? So half of this squared is 9. If I add 9 to the left side of the equal sign, I have to add 9 to the other side to keep it balanced.
Oh,
So sometimes, if I don't have a equal, sometimes I go add, subtract from the same side. So this step right here could have been done just like this. Okay? Where this right here is still my perfect square trinomial. And if I go 2 minus 9, that becomes -7. Add the 7 to the other side.
okay.
Does that make sense?
Yeah.
So it's your choice how you want to do it. If I have an equal sign, I'd say, hey, I do the same thing to each side. If I don't have an equal sign, you add and subtract. Yeah.
Can you put the 2 on the other side at the beginning?
Yes, absolutely. Yeah, go to make your space, move the 2, leave the space. We're good so far? Everyone happy?
I don't think anyone's spacing out.
Find the value of the discriminant. All right. So if this is positive, 2 real. If this is 0, 1 real. If this is negative, 2 complex. Does that make sense? Where does that discriminant hang out? Underneath the square root sign of the quadratic formula. So that's your b squared minus 4ac. B squared minus 4ac. If it's positive, 2 real. If it's 0, 1 real, it bounces. If it's negative, 2 complex. Yeah.
Can you do this, for example, just given a graph and you're trying to find the numbers of them using square root?
I probably won't give you a graph that you have to generate off of. I might give you a graph saying what kind of solutions are these, and you'd have to either say 2 real, 1 real, 2 complex.
Okay.
And do you need me to go over those?
No, it's fine.
Because
That's cool.
2 real.
That's so cool. Someone sitting next to them.
What'd I do?
Putting your little name.
1 real.
Complex is just not touching that.
Just wait.
Yep, don't cross the x-axis.
You'll deserve.
And then solve the quadratic equations using any method you choose, except looking, not your neighbor.
I like that one though. This is the best method.
So is a sure suit that.
Watson, I know who sits around you. They ain't that bright. I can't. Oh, hey guys. I'm just kidding.
Are you though? Are you kidding me?
Funny guy over here.
I'm not a mushroom.
That was the stupidest. That was what?
Fun guy.
I'll get that one on the walk home.
All right.
That was
What? We have 4 minutes. What would you like to see more of that you're not quite sure of?
This is third look.
That? What do you mean that?
It's on the board. I don't know.
Who's your stirrup?
Well, why are you reading a book while we're reviewing?
yeah.
How do you know
Because
the
then she
stirrup?
How do you know that the discriminant's like greater than or 0 or equal?
Oh, okay.
Just above the x?
Right.
Yeah, so you have your quadratic formula. So there might be multiple ways. One, we might have you say, hey, what kind of solutions would this have? And if you plug in b squared minus 4ac, if it's a positive number, there's 2 real solutions. If you use your quadratic, you get 0, you have 1 real solution. If it's negative underneath there, 2 complex. That's all you have to do.
How do you know when to use the quadratic function?
When you can't factor it easy enough. So the quadratic formula, if it were solving things, This is my last resort. If I glance at it and say, oh my gosh, I think I can factor it real quick, go for it. If you look at it going, you know, if you have something like this, I'm going quadratic formula all day long on that. But let's say I have something like this. I'm going to say, you know what? I can factor that to 2x plus 1, 2x plus 1. Okay? How did I see that right away? Because I have a perfect square and a perfect square. Okay? Yeah.
X plus 7. X squared plus 7.
Who's Andrew?
Is that right? Okay, subtract 7. 5 by 4. This root. So I'm going to get x equals plus or minus I root 7 over 2.
Okay, yeah, I get it.
It's just a,
Yeah.
look. It's the third piece. I intricate design. That's talent right there.
Talent.